Good afternoon. My name is Omdad Kosyal. I'm based at the University of Reading, and I'm one of the co-investigators in the Future Urban Ventilation Network. So before introducing Paul, just say a few brief words about the network for those who may not be familiar with it. If you're here for the first time, for example, we do have a website with a lot more detail, but just very briefly, the Future Urban Ventilation Network aims to develop a technical framework to enable an integrated approach to urban building design and technology. And it aims to create a strategy based on a health evidence approach and considering indoor-outdoor flows and in the context of air quality challenges, both current and future, hence the name of the network, and also the impacts on thermal comfort, noise, and energy use. There are a few sort of housekeeping rules before we get going. If you have any questions, usually we ask you to type the questions into the chat channel. That's the default rule, but Paul has said that he's happy for people to just ask questions during the presentation to make it a bit more interactive. So we'll deviate from the usual rule to some extent today. Otherwise, if you're not asking questions, please keep yourself on mute. It helps to eliminate background noise. And also, of course, goes without saying, please respect other participants' contributions. Just to make you aware that today's event is being recorded. And if you are on Twitter, you can tag your tweets with @BreathingCity. Okay, so just very briefly, the network consists of 15 co-investigators from UK universities and also Public Health England. And the PI is Professor Kath Noakes from Leeds, and the network coordinator is Helen, also from Leeds. We have 16 partners from industry and professional bodies. So that's basically the just a very quick summary of the network. And oops. Yeah, so just to briefly introduce Paul. Paul tells me he has been at the Met Office since 2000, and he manages their air quality and composition team, which is part of the atmospheric dispersion group. And the team is responsible for developing the AQUM model, among other things, and also delivering the Met Office operational air quality forecast. The team also undertakes consultancy work, applying atmospheric composition modeling expertise to a variety of customer problems, including health impacts of air quality and atmospheric dispersion modeling. So Paul will tell us all about this in his talk, which is titled An Overview of Met Office Air Quality Modeling Developments. So over to you, Paul, and thank you very much for being here today.
You're welcome. Thank you, Omdad. I'm just going to share my screen and get that to work first. So let's have a go. So hopefully you can see my screen now, and I'm just going to go into presenter mode. So hopefully you can all see my my slides there.
Yes.
Excellent. So good afternoon, everyone. As Omdad said, please do shout out and interrupt me as we go along. I'd like this to be interactive and to have questions as we go. If you want to save your questions till the end, that's fine as well, but more than happy to take interruptions. This is something of a random walk through various aspects of air quality, which are hopefully relevant to your project, your network. My main focus at the Met Office is regional air quality forecasting, which is a very particular aspect of air quality modelling and air quality studies. So I thought people would be interested in just an overview of our forecasting system. I'm probably going to go through that quite quickly because actually there's quite a lot of difference between the focus of my work, which is on regional air quality modelling and forecasting, and what I think is you're trying to achieve with the Breathing City network and the challenges that you face. So then I'll move on to just some random thoughts of mine just about some of the challenges of air quality modelling in the urban environment and how that differs from the regional air quality modelling and prediction problem. And I'll just say a few words about both the indoor and the outdoor environment. I'd then like to tell you about some of the new developments that we're involved with here at the Met Office, and some of the projects that we're involved with and that are upcoming, which I think are relevant to the to Breathing City. Some of the data sets that we have available and which we're developing, which may be of use to you in your work, and then we'll finish up with time for questions and discussions. So here we go. Just a little bit then about the Met Office air quality forecasting system, and just to start by showing you what our end product is. So the Met Office provides the.
Well, he won the boss then anyway. Nick Stanley was, and he said.
Okay, we had a bit of an interruption there. So the Met Office provides the National Air Quality Forecast for DEFRA. And what you can see here on the right-hand side of my slide is a screenshot of the UK Air website, where every day the Met Office air quality forecast for the UK is presented to the public. It consists of, for each of the 5-day forecast window of the service, it consists of a contour map of the daily air quality index over the whole of the UK. This screenshot was from a day in October, which was not particularly interesting for air quality. So it's mostly shades of green with a little bit of moderate index over London. But the actual customer facing products are the maps, and then a text forecast, which is written by my colleagues in the operations center, which really is just a short, in note form, description of the UK maps for today, for tomorrow, and then for the outlook periods, which goes out to 5 days ahead. This web page is supplemented by also a tweet which goes out on Twitter. The maps, are the main thing that comes out of the forecast model, but often there are some nuances which are not conveyed in the maps, and so we use the text there to add some additional information which the forecasters feel is relevant. So that might be about local effects. It might be if there's a pollution episode going on, the forecaster might choose to say something about what's causing it. And sometimes when the model makes a bad forecast, the forecaster might need to step in and say, actually, the model's not doing very well over Wales. The actual air quality, the actual pollutant levels may be either lower or higher than is indicated in the maps. But that's what we present to the public, and that's what all our work is focused on. So a little bit about the what's going on behind the scenes there. So our forecast model is developed with a configuration of the Met Office Unified model, which is our main weather and climate modeling computer model. So going back, let's see, to about 2005, we added the capability to include modeling of chemistry and aerosols. And then we use that configuration of the model to generate the air quality forecast. The model itself is it's a regional model. It's of the order, the grid spacing is of the order of 11 kilometers over the UK, with a time step of 5 minutes temporal resolution. And as I say, it's a regional air quality model. So it provides a good representation of the ambient air pollution away from strong sources of pollution. But of course, in the urban environment, people are living very much alongside the strong sources of pollution, which are typically roads or buildings or factories and so on. I've just shown on the right-hand side there a picture of the emissions map, which is one of the things that goes into the model, and you can see the emissions there for nitric oxide over. And this image actually also shows the domain of the model, so you can see that we don't just model the UK itself. We model a good portion of Northwest Europe, and of course that's important because pollution from Europe is easily able to, when the winds are flowing in the right direction, to be transported over the UK. The emissions that we used, we're very fortunate in the UK that DEFRA supports the compilation of a national atmospheric emissions inventory, which is a very detailed, at 1 kilometre resolution over the whole of the UK. It gives annual emission totals for all of the air quality pollutants that are needed to make the air quality forecast. Just delving a little bit into some of the technical details of our model. I said we model atmospheric chemistry. So there's a whole spectrum of complexity in modeling atmospheric chemistry. I would characterize our model as having intermediate complexity. It is a full tropospheric chemistry scheme. We don't model the stratosphere, but it has all of the key alkanes, alkenes, hydrocarbons, which are commonly found in the troposphere. We have 40 transported species, with 16 of those species being emitted. We also have some non-advected species. We model 116 gas phase reactions, plus an additional 23 photolysis reactions. And photolysis reactions are reactions which are
It seems we've lost Paul here, I'm afraid.
I'm just trying to contact him now.
Okay, thanks, Helen.
Okay.
Apologies about this. It seems we have a technical problem.
probably weather related.
I can see he's still in the call, so it might be that he's well, he's just left the call, so maybe he's rejoining now. Please bear with us. Sorry about this.
Have to sing us a song, Helen, in the meantime.
Don't tempt me.
I can get my guitar out if you want. Here we go.
Can you hear me, folks?
Yeah, we can
Yep.
see you.
Yep.
It was working on my side, but obviously it dropped off for some reason.
Oh, okay.
Let me go back to sharing my screen.
Yeah.
Oh, it says host has disabled screen sharing.
Change that now. There we go.
There we go. Okay. Are you able to see my slides?
Yeah.
So if you just do screen share. Yeah, there we go. That's perfect. Thanks, Paul.
Okay. Let's see. I think you probably saw most of this slide, and I was just saying something about the gas phase chemistry and the photolysis scheme. Okay, I'm just going to move on then. So the obviously there are two main aspects to air quality. There are gas phase pollutants, but there are also aerosols, and we use an aerosol scheme that was designed for climate studies. So it's not perfect for air quality, but we had to adapt that. It's what's called a single moment scheme. It just predicts the total aerosol mass. It doesn't worry about the growth of particles in the atmosphere. But it does have two-way coupling to the gas phase chemistry. And it covers a range of aerosol components, so black carbon, organic carbon, sulfate, nitrate, and dust in the atmosphere. So any kind of atmospheric composition model, unless you're a global modeler, material will flow into and out of your domain, and so you have to treat those flows with what we call lateral boundary fluxes. And so our model is embedded. Our Northwestern Europe model is embedded in a global model, and we take boundary conditions for meteorological variables from the Met Office global forecast model. And then there's a model which runs at the European Centre for Medium Range Weather Forecasting in Reading. It's called the CIFS. It's the chemical version of the integrated forecast system. And that provides us with inflows of pollutants at the boundaries of our model. And that's a very important source of pollutant into the UK domain. We carry out some sophisticated verification of our model, so comparing our forecasts against what actually happened in reality. We're very fortunate in the UK again to have a very good UK network of air quality observation sites in both urban and rural locations. That's the AURN. Typically, sites will measure sulfur dioxide, ozone, NO2, NO, carbon monoxide, and the 2 PM, the two types of PM, PM10, PM2.5. And it's a really great way of just checking on the forecast and the model and how it's running, both in near real time, but also for understanding biases in the model, and it helps us develop the model better. So I've just shown on the left-hand side there a time series of the black dashed lines are the observed levels of ozone at a site, and the green is the forecast model. So that's useful for site-specific verification, but also it's sometimes useful just to look at the spatial variations, and so obviously we use contour maps for that, and there's an example there on the right-hand side. Air quality models are not as skillful as weather forecast models. You might think, what does he mean? Weather forecast models aren't that skillful themselves. And that's true. Of course, they have errors, and we're all familiar with those. But in an air quality forecast or in an air quality model, you have all of the uncertainties and errors that are involved in a weather forecast. But in addition, you also have errors and uncertainties due to other things, such as uncertainties in the emissions, uncertainties in the and errors in the representation of the chemical reactions in the atmosphere and the evolution of both the chemistry and the aerosols. And so it's particularly important to use the observations as cleverly as you can. And so one thing we do, in addition to just using the observations for verification and checking the forecast after the event, we use the observations in near real time to inform us about how the model is performing with respect to the observations. And where there are errors and differences between the two, we compute biases which can be applied to the model to improve the forecast. And it's a very important aspect of our forecast system. And I've just shown an example there on the right hand side where you can see the observed values in the black dashed line. The unadjusted raw model is the orange line, and you can see it's substantially different from the observations. The bias corrected line is the green line, and you can see that gives a much better representation of the actual values of PM10 compared to the observations. So just in summary then, our forecast system comprises a three-dimensional gridded model. We use the observations to produce bias corrections to the forecast. We produce the forecast products themselves, which are these maps of daily air quality index. And then we also carry out quite sophisticated site-by-site verification against the UK observation network. So I'm just going to stop there and pause to see if there are any questions on the forecast system that I've just described. Okay, no questions. So I'm going to move on.
I've got a quick question. So,
yes.
In your automatic urban and rural network, how many of these sort of typical data collection centers are there? Is it 1,000 or 10,000 or?
Yeah. So the AURN, I have to say, it's not a Met Office network. We actually have nothing to do with it.
Fine.
Other than using the outcomes of it. It's funded by DEFRA, and it's run by a company called Bureau Veritas.
Yeah.
And it's organized by another company called Ricardo. So in the AURN, I don't have the accurate numbers to hand, but taking into account all of the observation sites, they're of the order of 100 sites. It's certainly closer to 100 than it is to 1,000.
Okay.
And there's a split between there are different site types. There are rural sites. Well, actually, there are two types of background sites: rural background and urban background.
Okay.
And then there are traffic sites as well.
Yep.
And then there are some subdivisions like industrial sites and curbside sites and so on. But it's of the order of probably between 100 and 150 sites in the UK.
Okay, lovely. Thank you. I think we've got some folk in the chat who've pitched in as well. And there's a link
Do
there.
speak out, because I can't see the chat at the moment.
Right, of course. Yeah, that's a weird thing, isn't it? So Ian has suggested there's about 300 in AURN, about half of those in London. And Alison has suggested a few hundred in total. But many are roadside or urban background. Yeah. Okay, brilliant. Thank you. Well, thank you, everybody. It's very, it's a great response to my question. Thank you. Yeah.
Because of our, as I said, the fact we produce a regional forecast.
Yeah.
We only use the background sites in our forecast adjustment processing scheme. Because if we used roadside measurements of pollution, obviously that would those measurements are only valid over a relatively short distance.
Yeah.
So it's the background sites which are of most interest to us.
Yep. Thank you.
Okay.
So Paul, who's the main user of this this data then? If it's a regional forecast, but it doesn't cover the strong influencers, who would use it?
So it's a forecast for the public. So the idea is that people who have, well, any member of the public, of course, but in particular, vulnerable users, so people with breathing conditions, COPD, asthma, people who are particularly affected by poor air quality, can take action if they know that poor air quality and elevated pollution levels are coming in the next 5 days. They can ensure that they have they're stocked up on their medicines, and they can plan their activities. So if there's a day when we have high levels of urban pollutants, then obviously that
Oh dear, looks like we've lost Paul again.
You just unmute. I think he's just gone on mute. He's okay.
I think you're on mute, Paul, for some reason.
Unless it's put him on mute because he's not sending. So the Zoom thing puts him on mute because it can't see him.
can you hear me now?
Yeah.
Okay, I think Zoom must have automatically put me on mute or something. Okay, let's carry on. So I was just speaking to who uses the forecast, and it's aimed at the public and in particular vulnerable users. And so if they have warning 5 days ahead of poor air quality coming, they can stock up on their medicines and they can plan their activities accordingly.
Well, you'll need to reshare your slides as well. For some reason, it's gone.
Okay. Yeah. Okay.
That's great. Yep.
Okay, that's gone through to back to the beginning. Okay, so just some comments about urban air quality modelling. So the requirements for urban air quality modelling. Well, of course, you tend to need very high spatial resolution models because close to sources pollution is very inhomogeneous. Next to a road, levels of pollution can be very high, as little as 20 or 50 meters away. They can have fallen by an order of magnitude. So high resolution is very important if you want to capture those spatial gradients. You need accurate knowledge of emissions. I mentioned the NAEI earlier. It only provides annual totals of emissions. and then the modelers have to impose temporal variations. So we apply day of the week variations and hourly variations throughout the day to capture things like rush hour during the day. If you're interested in even finer detail of what's happening close to a road, then you might need to apply even higher resolution temporal emissions, and one could imagine systems which are actually counting cars as they come down the road and predicting emissions on that basis. The representation of meteorology in the urban environment, there are specific factors of the urban environment which mean that the representation given by a regional weather forecast model may not be adequate. And in particular, you need to account for features which are influencing the urban environment. So that could be things like accounting for street canyons, for urban heat island effects, accounting for the interruption of solar radiation reaching the surface due to tall buildings. Those things will all have a significant impact on your predictions at street level. But it very much comes down to what you're trying to do and what you want to know in terms of what the detailed requirements are. So in terms of regional air quality modeling, the challenges that I face are, improvements to the resolution. I mean, more resolution is almost always good. The accuracy of the emissions. I mentioned the NAEI, and again, just to say that even in the the official emissions inventories, how trustworthy is the data? We all remember Dieselgate from a few years ago, where it became apparent that some of the car makers were fudging the data. It would be naive to think that the emissions published by car makers are almost entirely accurate. The accuracy of the meteorology is a key thing for modeling outdoor air quality at any scale, and then the sophistication of the treatment of chemistry and aerosol. So for outdoor urban air quality, so moving to the urban environment rather than the regional domain now, you've got all of the above challenges, but or most of the above challenges, but even more so. So you still need accurate, but you need higher spatial and temporal resolution for your emissions data. You need higher and high quality spatial and temporal meteorology. I mentioned some of the particular factors in the urban environment, and I know that that some of the people who are involved with the network are experts in some of these things, much more so than I am. One thing which is probably less challenging is that generally, I think for outdoor urban air quality modeling, the role of chemistry and aerosol processing is probably somewhat less important for two main reasons. One is that the pollution and the air pollution is usually dominated by the emission of the primary pollutants directly to the air. The secondary pollutants are somewhat less important when you're close to the source. And because of that proximity to the source, the timescales that that are involved to allow chemical and aerosol evolution in the atmosphere is generally shorter. So there's less time for chemical reactions and aerosol growth and so on. When we move to the indoor urban environment, again, there are some things which are harder. There are some things which are actually easier compared to outdoors. So probably things which are harder. So indoors, there's a much greater list of species that you may need to worry about. You know, there are up. You know, one sees numbers quoted of there being, you know, from the chemists who have performed very sensitive evaluations of the air in the indoor environment. You know, they can detect, you know, upwards of 900 different species in the buildings, but that's too many in a sense for us to try to model in detail. So which pollutants are we going to try and model in detail? So for the outdoor environment, we have a daily air quality index, and it only concerns 5 pollutants: SO2, NO2, NO, ozone, and then the 2 particulate matters. And I feel that what's needed for the indoor environment is for there to be some equivalent where we try to set out which are the key pollutants to be worrying about indoors. And another aspect of indoor pollution, which is perhaps more important than outdoors, is the role of bioallergens within the house. Obviously, outdoors, you know, we have pollen, but we separate pollen from air quality. Is that a viable separation indoors, whether there are other bioallergens? These questions have not really been considered in great detail, and no answers exist. So it's still work to be done. We need better characterization of the emissions in the indoor environment. And obviously, a lot of the emissions come from human activity within the house, or the office block, or the factory. And so which indoor environments? You know, there are very many different types of indoor environments, and is it, again, just like there are many different types of indoor pollutants. So to make progress, I feel that we need to have, you know, a list of characteristic environments which typify certain types of buildings. Some things which are probably easier when it comes to modeling the indoor air quality. Well, obviously there's generally less sensitivity to the external meteorology. There are some, there clearly is coupling between indoors and outdoors, and there are, you know, all buildings, you know, transmit and transport air from outside indoors and vice versa, but generally at relatively low levels. So there's much less sensitivity there to the details of the external meteorology. Some of the indoor environments, our outdoor air quality model has upwards of 25,000 grid boxes nested within a global model. Some indoor environments can permit much simpler what we call box modeling, where you just have, you know, essentially a single box. You can treat the house as a single box, or you at its most simple level, that may not be a massively poor approximation, or going up in sophistication, treating each room as an individual box, which has linkages to the other boxes, the other rooms within the house. And then in our outdoor air quality models, I talked about the lateral boundary conditions, which is the air exchange with the rest of the continent. Obviously, for buildings, accounting for air exchange within with the outside is generally a much simpler proposition. Okay, moving on to some new developments that I'd like you to be aware of. There are just 3 that I want to talk about. Where are we? And the first one, I'm not going to say too much about, because I looked at some of the past presentations that your network has had, and I know that my friend and colleague from CERC, Amy Stidworthy, gave you a presentation, I think it was in September, on something called the MaxHealth project, which is part of the Clean Air project, which is coordinated by the Met Office. And this MaxHealth project is being run by Amy's company, CERC. And basically, it's a project to couple air quality modelling at the regional level down to the urban environment and the street scale environment. So just like our regional models are nested within global models, then this is adding another level of nesting within that down to the urban and street scale. So I commend Amy's presentation to you from September as the best place to learn more about the MaxHealth project. And just to add that the Met Office, as well as coordinating some of these projects, we are actually beginning to use the MaxHealth system to couple our own air quality models to the urban model, which CERC use, which is ADMS, using this MaxHealth framework. A development which we are making with our own models here at the Met Office. So our primary forecast model at the moment is the AQUM model. I said it's a model which is a configuration of the Met Office unified model. So AQUM is just the air quality version of the UM. For a variety of reasons, we are looking in the future to moving away from that model. It's a grid-based Eulerian model, and that has many pros for air quality modeling, but there are some cons as well. One con is that you can only place emission sources at the nearest grid point, because the model only exists at grid points. In another type of model, a Lagrangian particle following model, there is no grid as such, and you're not constrained by a grid. And we're developing a hybrid Eulerian Lagrangian air quality model based on the Met Office name dispersion model, but interfaced to the UKCA submodel for chemistry and aerosols. And we think that will give us greater flexibility when it comes to defining sources. So that will be a big help in the urban environment. Improved treatment of point sources, so dealing when it comes to dealing with industrial sites, for example. But it also allows the model to be run backwards in time, and with that capability, you can do source attribution studies. So you can do some interesting science to work out where pollution at a given location is coming from. I've mentioned the Clean Air project in the context of MaxHealth. It's a big project which is now in its third year, and it's rolling onto the second wave. And earlier this year, we tendered for bids for a new project focused on indoor air quality emissions and modelling. And the aim of that project was to identify some of the key pollutants for indoor air quality, to develop some tools for allowing researchers to generate emissions in the indoor environment, and then also to develop more developments of existing capabilities or a new modeling capability, which can be used to model indoor pollutant levels using the emissions developed as part of the project, and within some representative representative building types. That work will commence soon, starting in January. It's a 3-year project, and so I would advise the Breathing City Network to keep an eye on that project and see how some of the work that comes out of that project can help you in your work. In terms of Met Office data sets for modeling air quality, some of the data sets which may be useful to you. Obviously, we provide data sets which are available publicly of high resolution meteorology. And that is open to anyone, and I would commend that meteorology as a very good data sets to be using if you want a good representation of meteorology in your modeling work. Just to be aware, some of these data sets are just surface level meteorology, and if you're modeling things like tall buildings, there may be some adjustments to the data you need to make. The meteorologists will all know very well that as you move away from the surface, wind speeds will typically increase rapidly with height, with under neutral conditions, a logarithmic profile. So for tall buildings, the wind speeds near the bottom of the building can be much lower than the wind speeds at the top, and you'll probably want to take simple things like that into account with your modeling. In terms of air quality data sets which could be useful for you if you're doing hindcasts, so the Met Office we now have made available to the public and to researchers, actually to researchers is probably a better way to say it, a data set of hourly surface air concentrations of the air quality pollutants at 2 kilometre spatial resolution over the UK, going all the way from 2012 to the present day. So if you want to use that data to provide, for example, boundary conditions for an urban model, that would be a very good data set, I think, for people to use. And a piece of work that we're currently doing, and which will be coming soon, hopefully in the first half of next year, is that we are computing a reanalysis of UK surface pollutants as above, so all the air quality pollutants and it's actually going to be from 2003 up to 2019, and then we will add new years as they become available, but it will be hourly surface concentrations of those pollutants. So that's a very long time series computed in a consistent way of pollution for essentially the last 20 years over the UK, and it's going to be an incredibly useful data set, I think, in particular for people who are interested in looking at health impacts of air quality and comparing air pollution levels with some of the health data in the UK, like hospital admission rates, GP visits, and these things. So some three data sets there, which I think could really benefit some of the work that you are doing. And that's all I want to say. So let me open the floor to all of you with any questions now. I'm going to stop sharing.
Thanks a lot, Paul. That was an excellent overview of the work that your group is doing, and it was also very useful to hear your views about some of the current issues. Yeah, so we do have quite a few questions in the chat here. I don't know whether, can you see the questions?
I can see the chat now.
Okay, that's great. So we have maybe if we take them chronologically, starting from I think the first question was from Lewis Blunt.
Okay, so Lewis, hi Lewis. So the bias correction, Lewis, we essentially we evaluate the model bias at measurement sites, looking at yesterday's observations and yesterday's forecast. We then spread that bias spatially using a kriging technique. So we have a gridded bias based on yesterday's forecast. And then essentially we persist the bias into the following day, and then we persist it into the second day, and then we have a weighting function as we go out with time, where we relax back to climatology. But essentially, we correct the bias based on yesterday's observations, and it's a spatially varying correction, and it's very effective actually in correcting short-term biases in the model.
Thank you.
Okay, next question from Alison. Even at the regional level, cities will affect flows close to the surface. How do you account for urban roughness lengths? Okay, so in the regional model, so it's a configuration of the so it still has a representation of surface roughness and heat islands and so on, but it's at the regional scale. So those are all treated in the same way. The models have essentially ancillaries which represent surface roughness and surface heat capacities and so on, just in the way that any higher resolution model would as well.
Specific account taken for buildings and the inputs of buildings, or is the scale too large?
Sorry, I couldn't hear that, Alison. Just say that again.
So is there specific account taken of the surface roughness due to buildings, or is the scale just too coarse?
So in our model, we're using quite a relatively old urban tiling scheme, not the latest one. So there will be some account taken, but not at high resolution, and it's not. I mean, we have some very high resolution. We have a London, I think it's 300-meter model resolution model, which would do a much better a job of urban roughness lengths. Ultimately, we're limited by our grid spacing of 11 kilometers, so inevitably things get smoothed out quite a bit. Do you feel that the model could be improved if there was closer liaison with air quality officers? Probably. I mean, we do have close links with a lot of people who are involved with air quality. In terms of local authority air quality officers, I don't know if that's what you're meaning in particular, Dave. I'm sure they have something useful to say. Obviously, a lot of what we do is, it's nitty gritty of implementation of meteorology, emissions data sets, detailed atmospheric chemistry modeling. But I wouldn't want to say that air quality officers couldn't contribute to those things. Councils may have their own air quality stations. Yeah, absolutely, yes. So near strong sources. Yes. So we don't use our, as I said earlier, we don't use our bias correction. We don't use those sites because they would give a bias which is not representative of a large spatial area. Hi, Kaya. Good to see you again. Hope your new job's going well. how does the bias correction work if the observatory is missing? So, so because if a particular site is missing, it's not great, but it's not massively problematic, because we use this kriging process. We essentially produce a grid, and it just means that we don't have a constraint at the missing site. So we will still have some bias correction, but we'll be missing that particular observation site. How would you use the interpolation between nearby sites? Well, again, if the sites are particularly close together, again, because we put all of this ultimately onto a 2-kilometer grid, then that would be taken into account in that gridding process. So Dave, for the above, referring to local authority staff. Yep. Yeah, the local knowledge, I think, is very important, Dave. Of course, and I think for people who are modelling urban air quality, it would be very wise for people to develop links with people to build on their local knowledge. With our system for our regional air quality modelling, local issues are of probably somewhat less importance. You say here it could also help inform the public. Absolutely, yeah. And many local, well, I don't know many. Some local authorities, have their own websites with detailed local air quality information on it, and obviously that one would expect that to be very useful and for people to be looking at that. Alison, not sure.
I can explain. This is me moaning, basically. I tried to download some Met Office data to use with ADMS, and I really did find it quite torturous. Trying to get all the information that you need in terms of wind speeds and also stability information, so information that relates to boundary layer heights or surface information. It was all in different places, and it was quite difficult to put together. So I think there's scope there.
Okay.
You could help us out more.
Yeah. So yes. So what I would say, Alison, is I mean, you probably need a range of variables which go beyond what most or many users would require.
Well, I was just using ADMS.
Right. So okay. So atmospheric stability. So what is that? What is that particularly? What is that? The Pascal stability class, or?
Well, cloud cover or surface radiation is one way of describing it. So, but what I found was that all the wind speed, wind direction data was coming from one data source, and information related to stability was coming from a different source, and you literally had to merge the lines of the data set yourself.
Right.
Anyway, it's just a comment.
Yeah. No, it's fine. Did you feed that back to the to anybody at the Met Office? I mean, it's yeah, it's.
I did have some communications.
Yeah. Do you have any links with some of the people in here at the Met Office? Some of the something like some of the people who do the the mesoscale modeling, because possibly for your application, making links with some of those people provide.
It was observation data that I was looking for. So data from
it was observation data.
Oh no, Christina agrees with me. I think you'll find. I mean, I think unfortunately, I think the setup is that if you're a consultancy like Ricardo doing air quality assessment, you would pay the Met Office for the data set. Somebody at the Met Office will sort it out and then send it to you. But obviously, in academia, it's particularly related to student work, we can't do that. So,
sure.
Yeah, I do think that the system is quite obtuse.
Yeah. Okay.
And you know, there's a lot of data there that that could be of help for air quality modelling, and the data's there. So you know, it's just slightly tricky to extract.
Sure. Okay.
Yeah, boundary layer depth is tricky. I agree with you, but the surface radiation and cloud cover, you know, they're in your data sets, aren't they? So
absolutely, yeah. Okay, I will pass these comments on, well, if you can send me your email addresses, I will follow up with you as to what comes back.
Okay, thank you.
So my email address is paul.agnew@metoffice.gov.uk. So what would be useful, Alison, is you just drop your comments in an email, just in bullet point form, and then I will speak to some people here. I'm not promising to change the world here. The Met Office is a super tanker, which it's very hard to change direction. But sometimes just finding the right person to speak to is half the problem. So I can probably help with that.
Yeah, thanks a lot, Paul. Thanks again for your great talk, and I'm very conscious that we've gone beyond time here, but it was a very stimulating session with lots of questions, and you know, you did a very good job in clarifying some of the questions. So thank you again, and thanks everyone for attending, and we'll see you next week. And